You back once again in study battle. So as you would have seen in the thumbnail that we will be discussing today the second part or the second paper of civil services means geology optional. So if you have not watched the first video, you can go into the channel's playlist that I will provide the link of this first part video in the description of this video. From there you can also watch. Okay. So in this today's discussion, we will talk about the second paper, that is geology paper number 2, and you all will be fairly aware with the fact that the second paper consists of petrology section and economic geology section plus little bit of hydrogeology as well as the part of engineering geology also. Okay, few 2 or 3 topics of engineering geology also. So the general instructions are the same as we have discussed in the first part or the first paper. All in all, 5 questions have to be attempted, and you have to attempt first and fifth question is compulsory, and you have to attempt 2 questions, at least 2 questions from one part and other questions from the other part. Okay, so these are the instructions. So what is the first questions dealing with? So we all, that is first question and fifth question is compulsory, so you don't have to skip it out. Okay, you have to answer it, and in and around 150 words. So you have to adhere the word limit which is given in the instructions also. Okay, so first question is dealing with the Hermann symbol. You all are very familiar with the Hermann symbols for the crystallographic notations or the plane notation. So how does one designate mirror planes as well as the rotational axis of symmetry and the center of symmetry in Hermann symbol, Hermann rotation? A crystal has 1/4, so there is a question also. Okay, a crystal has 1-fold axis, 1 4-fold axis, 4 2-fold axis as well as 5 mirror planes, and also it has center of symmetry. Okay, so this is the question, and what will be its Hermann notation? So this is the question you have to solve, and you have to also designate the mirror planes, rotational axis of symmetry as well as the center of symmetry in these symbols. And you have to also show on a stereographic projection. There will not be provided, I don't think they will provide stereographic or that better paper to draw the plane projection. You can just, if they have not been provided, you can draw it with a loose hands onto your question come answer booklet. Okay, it's not necessary for you to have that butter paper in order to orient that axis. Okay, on a plain paper you can also draw it and crystal and plot the faces of the form like in the form of HPL. Okay, so this is the question that is little bit longer question as we can compare it. So it's 10 marks question. Okay, so you have to answer each and everything which is given here. Next one is dealing with discuss with the help of suitable diagrams the crystallization of melts having composition of diopside 70 and anorthite 30. Okay, so generally we study about the two-phase diagram, especially at 100%. Okay, so diopside 100% and anorthite 100%. Generally we talk about, but since here the composition has changed, diopside has 70% and anorthite has 30% of melt. So on that basis you have to discuss about the phase diagram, and under 1 atmospheric pressure. So pressure has also been assigned 1 at atm pressure, and after completing the crystallization, when the crystallization gets over, you have to also deal with what will be the texture of that rock ultimately formed on the completion of the melting process. Okay, when the phase process of phase diagram that completes, means when the melting process is completed, at the last the melt that is remaining, what will be the texture of that melt? That had also been asked in this question. Okay, so that we have to discuss. These 2 questions are little bit, they have been moved about. Okay, it's not that they are very tough questions, but they have been roundabout. They have been tweaked about, we can call them. Next question is continuous and discontinuous reaction series in Bowen reaction series. That's very familiar question, is very common question which is being asked. And the continuous and discontinuous reaction series in Bowen, by which has been proposed by Bowen, and why is one series called continuous and the other is called as discontinuous? So this is a common question, because the temperature that changes, temperature that varies when you go from the higher regimes to lower regimes. Okay, so this is the case on one side on the discontinuous series and continuous series. That feldspar series is continuous, and this olivine, pyroxene and amphibole, that series is discontinuous. Okay, and the temperature decreases as we move downwards. Next one is metamorphic related questions, prograde and retrograde metamorphism with suitable examples. Discuss the process of metasomatism also. So we all know that is prograde means the pressure gets, when the pressure increases, temperature also increases in prograde, in the case of prograde metamorphism. But when it changes to, when it shifts over to retrograde metamorphism, in that case the temperature lessens down, okay, with increasing pressure. Okay, so this is the case that we have to discuss, and the role of water that plays an important role in this retrograde metamorphic process, that also has to be dealt here. Next one is give a brief account of Folk's classification of limestone. So this is again very classical question of sedimentology that has been repeatedly been asked, whether you talk about the civil services means or the Indian Forest Services means, or you can call it in Geological Survey of India exam, that is the Combined Geoscientist means as well as. Okay, so on all these three descriptive types of exams, this question has been repeatedly been asked. Okay, so Folk's classification is based on the micrite, okay, micrite, pelmicrite, and the biomicrite, spericalcite. So this is the classification of the Folk's classification of limestone. Okay. Question number second is dealing with the give the classification scheme of silicate minerals on the basis of atomic structures. Okay, so atomic structure means that silicon and oxygen ratio. So generally we'll talk about, whenever we talk about silicate structures, we necessarily talk about the silica and oxygen ratio. On that basis we can define that this is nesosilicate, this is tectosilicate, this is phyllosilicate, sorosilicate, okay, or cyclosilicates. So that we have to talk about. Okay, with the sharing of oxygen, with the sharing of oxygen and silicon gives rise to different types of nesosilicates, sorosilicate, okay, phyllosilicates and tectosilicates. All these things have to be discussed here. Give suitable examples of each classes. For the each class we have to provide examples like nesosilicate, olivine for nesosilicate. Okay, there can be example of chain silicates in which the one chain and double chain silicates, where tourmaline, that can be example. Hornblende can be the example. Then can be example of mica in the phyllosilicates minerals. Okay, so this is the question that we have to discuss. It's 20 marks question. So obviously we will have to draw the diagram, means the silicon oxygen ratio in particular, all the conditions. For example, nesosilicates, you have to draw the diagram. You will have to show that this is the 4 atoms of silicon and they are sharing about the oxygen atom. Okay, so that has to describe. Nextly, you have to talk about the birefringence. Define the birefringence and extinction angle in minerals. So birefringence is very common process. We all know that is, we also call it the double refraction or doubly refraction. Okay, you all know that is, if there is an unpolarized light, if it's passing through an anisotropic minerals. Okay, anisotropic minerals means when they pass through any direction, when we pass through any light, they bifurcates in two direction. Okay, so an unpolarized light when passes through an anisotropic minerals, it bifurcates into two directions or two rays. Okay, one is known as E ray and one is known as O ray, ordinary ray as well as the extraordinary ray. Okay, so this is the concept behind birefringence. And also about the extinction angle, means how the minerals get extincted when we rotate the that circle, when we rotate the stage of that microscope at per 90 degrees. So when we rotate minerals 360 degrees, at every 90 degrees, the minerals get extincted. Okay, so that process has to be discussed here. How does one proceed to measure extinction angle of a mineral under microscopes? Substantiate your answer with suitable sketches as well. Okay, you can draw the sketches of and that uh, rotating cycle of that microscope. On that basis, you can tell that how at which angle at what point of time the mineral will get extincted for with a suitable example you can show. Okay, next one is explain different types of or define twin plane, twin axis or and composition plane. Okay, so in crystals, so all about the twinning. Okay, what is the twin plane, what is the twin axis around which the twinning takes place, and composition plane. And you have to also state different types of twinning of which has been observed in feldspar. Okay, so in feldspar, very common twinning which is known as the albite twinning. Okay, and there can be polysynthetic twinning in case of feldspar, and there can be one or two more, I don't remember exactly, but polysynthetic twinning is there. There is albite twinning which is very common in feldspar. Question number 3 is dealing with there is a little bit of geochemistry, I think. No, it's igneous petrology. Discuss briefly the process of magma generation in the Earth's interior, means how the process of magma generations take place. Okay, in brief you have to discuss because it's a long process. Okay, because geochemical that geothermal gradient comes to the out that crust, and when it passes to when it nears to the crust boundary, or when it moves towards the crust, then that process of magma crystallization takes place with the preceding depth also and temperature conversion also. Okay, how is grain size of an igneous rock related to the rate of cooling magma? Discuss the role of fractional crystallization as well as the assimilation in the process of magmatic differentiation. So it's a very classical question, very repetitive question. It has already been asked. Describe the various suitable sketches for different types of structures or textures which are being found in metamorphic rocks, and you have to also add a brief note on their origin, means how they are being originated. Okay, so any 4 type of structures or textures, you can talk about structures or you can talk about the structures. Okay, for structures you can call about the gneissic structures. Okay, there can be granulose structure. Okay, so this type of structures you can draw, or you can talk about the textures also, granoblastic texture. Okay, decussate texture. Okay, what is defined migmatite? How does the process of migmatization help to understand the origin of granites? That is also question related to the metamorphology. What is the provenance? How can we use clastic quartz, feldspar as well as the lithic grains in provenance interpretation of sandstone? Okay, so provenance we all know that is from where the originated. Okay, and when they originate from a particular place and they got deposited, they got transported, then subsequently got deposited in a particular sedimentary environment. So this whole journey, that is known as the provenance. Okay, from where the sediments gets originated, that place is known as provenance. Okay, and when we talk about the whole journey from that deposition, from that transportation, deposition, so that whole journey is known as provenance study. Okay, you have to also use the clastic. How can we use clastic quartz, feldspar as well as the lithic grains in the study of sandstone, provenance interpretation of sandstones? Next one is define a sedimentary facies model. Illustrate with the neat sketches the sedimentary facies and the association of facies likely to develop in a meandering fluvial depositional environment. Okay, you have to talk about the facies, sedimentary facies model, and you have to also talk about the fluvial depositional environment. Means what type of facies likely to develop in a meandering fluvial depositional environment. Okay, next one is describe the genesis of any 4 sedimentary structures which have significant significance for paleocurrent analysis. Okay, any four types, any four sedimentary structures. Okay, you can talk about ripple marks, you can talk about the current bedding, braided bedding. Okay, sorry, cross bedding you can talk about, ripple marks you can talk about, or you can talk about, like for example, flute marks you can talk about, because they all these three or four sedimentary structures, they provide a complete study about the about the paleocurrent, means what was the direction of movement of water or wind as the process at the formation of that structure, or at the formation of that rock. Okay, so this is the question here. Question number 5th is dealing with the, this is an numerical here, lead mineralization zone that has been drawn in the given diagram with the nomenclature, means nomenclature of the sections has been given there, and you have to, the related data in is also provided in the table. Okay, you have to calculate the average grade of the lead in percentage. Okay, so here four, one second. Okay, four samples have been given and their zone of influence has been given, width has been given, and width into length square has been given in feet square, as well as the percentage. Okay, so for all the four samples the data has been given, and you have to talk, you have to deal with the, or you have to tell about the percentage of grade percentage, average grade of lead in percentage. Okay, so this is a numerical here. Describe the geological nature of coal deposits of Jharia, or Jharia means Jharia coal field that is in Jharkhand. Okay, so Jharia coal field that is in Jharkhand, that stratigraphically it's like Talchi, Barakar. Okay, so these are the formations which are associated with Jharia coal field, and you have to also comment on the economic potential, means how much potential, how much deposits, coal deposits are there. Okay, so that we have to talk about. So you can provide here the latest data of the occurrences or the economic potential of Jharia coal field if you have that data. Otherwise you can just predict it, that how much of data can be there. What are the geophysical methods of exploration, and how is gravity methods used in useful in the mapping of metallic ores? So okay, this is a very again repetitive questions, you can discuss it. Geophysical method, you can describe the geophysical method, different types of methods like seismic methods, electrical resistivity method we can call them, or gravity methods, magnetic methods. Okay, and in electrical methods there have again several types of methods. Okay, so that we can talk about here. Next one is define trace elements, discuss the possible ways that a trace elements can enter into a mineral structure. Okay, so this you have to talk about. State the sea level changes in late Pleistocene period. Okay, especially in late Pleistocene period, how the sea level has varied with possible causes. You have to also talk about the causes. Okay, so I think one of the most important causes for the sea level changes, that was the glaciation period, because late Pleistocene was the time of glaciation when the sea level that also varied. So that's why the sea level has fluctuated, because the sea level varied. Okay, and the ice age was there, the ice deposition that also took place in the sea level, that's in the oceans, that's why sea level has varied. Okay, so that we have to talk about. Add a note on the anthropogenic causes occurred in the last 2 centuries. Okay, so that we have to also discuss here. Give the modern classification of mineral deposits and explain in brief the residual and mechanical concentration deposits with suitable examples. Okay, so modern classification of mineral deposits, that you can talk about, and also you have to briefly you have to discuss about residual and mechanical concentration deposits. Okay, stating the premise of national mineral policy, NMP we can call them, in acronym form we call it NMP. Give the outline of strategic, critical and essential minerals citing Indian examples. Okay, so this is a very common question, very easy question you can call them. Okay, So you have to talk about all the three minerals. Okay, static minerals, critical, as well as the essential minerals with respect to the National Mineral Policy (NMP). So the year has not been mentioned here in NMP, so you can discuss about the latest one or the previous one also. Okay. Give the mode of occurrence, distribution, and the use of manganese deposits of India. So that we have talked about already. We have discussed this video. You can get it from the channel's playlist, Geology paper number 3. In that playlist, you can get this video of the manganese deposits of India. Okay. So you have to talk about the occurrences, their distribution, as well as the uses. Okay. So mainly you have to focus on these three topics. Means occurrences means where these minerals or where these manganese minerals are occurring. Okay. So this is the question here. State the characteristic features of cosmic abundance of elements and what are the basis of estimation of cosmic abundance of the elements. Okay, so this is also again very important question or very basic question we can call them. Discuss briefly with examples about the different types of chemical bonds which are available, which chemical bonds observed in natural minerals. Okay, so 2 or 3 or 4 bonds are there. Okay, that is the covalent bond, ionic bonds, okay, metallic bonds, as well as the van der Waals bond. Okay, so these are 4 basic chemical bondings which are occurring in the minerals. Okay. Next one is describe briefly the geology, structure, as well as the mode of occurrence of hydrocarbons in western oil fields of India. Okay, so in western oil fields means we have to talk about the Maharashtra, Mumbai, Bombay High region. Okay, as well as the Gujarat region in which the Cambay basin is there. Okay, and several others other basins are also there. Okay, Ankleshwar oil field is there, Cambay basin we have already talked about, Bombay High is there, and new researches are focusing that the availability of hydrocarbons that is also in state of Rajasthan, for example Jaisalmer in that part also. So studies are going on, so you can talk about, especially if you don't have the recent data about the Rajasthan state, you can talk about the Bombay High as well as the Gujarat portion. Okay, especially you have to talk about the western oil fields. Next one is question number 8. How is unscientific development of catchments situated in the mountainous regions, they are responsible for the increased threat of flood in plains? That's very essay type of question, so you can cite some examples. For example, it's talk about the mountainous regions. Okay, so the floods which are taking place, for example, we can call them the Uttarakhand region or Himachal Pradesh region, in the mountainous regions. So that you can talk about. You can give the example of recent flood which has taken place in the Uttarakhand. Okay, where the power project, geothermal power project was going on the Tihri Dam. Okay, so that incident you can cite examples that how this has occurred. Okay, because of the unscientific development of catchments situated in the mountainous regions. Nextly, you have to describe various types of radioactive wastes and write an account on various methods for their disposal. Okay, so different types of waste you have to talk about and how we can inculcate, how we can cope up with this method of disposal, how we can dispose them. So one of the most important, very important process, that is the incineration process. Okay, with the process of incineration we can dispose the radioactive waste. Okay, there are others method also, but incineration is one of the most important process. Okay, where the radioactive waste is being fired in the chimneys through in the furnaces, and then it's converted into the slurry, and then it gets deposited, then gets disposed at some place. Okay, by this process the risk of that radioactive waste get decreased. So this is process of radioactive waste disposal that we have to talk about, especially the methods. Next one is what is meant by waterlogging, and describe in detail the remedial measures of waterlogging as well as the salinity. Okay, so this is again very proper question, very common question which has already been asked in the exams. Okay, so this was the Question number 2 of Geoscience Civil Services means Geology optional question paper 2. Okay, so I think question paper was not too tough. Especially in the second question paper like this numerical portion, if you are not aware with the concept, numerical portion could have been little bit tough. Otherwise question paper was easy to moderate. There was no tough questions were there. Okay, so in next video we will talk about some, and there is again a class at 8 p.m. today. You would have seen the thumbnail, you have seen the information there. If you have subscribed the channels and pressed the bell icon, you would have got that notification of this current video, and you would have got the notification of that video which is going to be live, which is going to be telecasted at 8 p.m. Okay, so in that video we will talk about the very important topic which is related to the San Andreas fault and the process of formation of San Andreas fault, and also the process behind that fault, that is the transform fault and the transcurrent fault. Okay, so you can join that class at 8 p.m. Thank you.